Hello everybody, today we're going to talk about finding surface area on cubes and rectangular prisms. To find the surface area of a cube is relatively easy. Keep in mind a cube has 6 faces and they're all the same area. The 6 faces of a cube make a square. So remember, the area of a square, you take the side and you square it. But since we have 6 faces, we just multiply that quantity by 6. And that gives us the surface area of a cube. So we got a few examples to go over with that. Notice the side of this cube is 8. So we're taking 8 squared, and 8 squared gives us 64. So really all we're multiplying is 6 times 64, and that gives us 384, and we're measuring in millimeters. So the surface area of this cube is 384 millimeters squared. Notice this isn't a volume. It's not millimeters cubed. That would be volume, but we're doing the surface area. Let's look at another one here. It says a table is shaped like a solid cube needs to be painted. All 6 faces of the table must be painted. The edge length of the table is 1.2 meters. What's the total surface area that will be painted? So just like our previous problem, we just don't have the luxury of a picture. 6 times 1 edge squared, and 1 edge is 1.2. Break this down here step by step. First we're going to take 1.2 times itself to get the area of one face or one side of this table, and 1.2 squared is 1.44. We then take 1.44 times 6 to get 8.64, and it is meters, so we're going to label it as meters squared. Okay, let's look at another one here. What's the surface area of a cube with a given edge length of 15 inches? Side is 15 inches. Alright, so 6 faces, one side is 15, and that side needs to be squared. 15 squared is 225. If you take 225 multiplied times 6, we get 1,350. Surface area of this cube, 1,350 inches squared. Okay, now we're going to shift gears a little bit and focus on a rectangular prism. Notice this 3D object. It's a little more complicated than a cube. 3 dimensions, length, width, and height, they're all different. Now if we were finding volume, all we would do is multiply 4 times 5 times 15, and that would tell us volume, but we're not. We have the surface area. Keep in mind there are 2 faces that are identical, and there's 3 sets of 2 different faces. Okay, so I'm going to mark one at a time, and we'll note that we have this rectangle and this rectangle. They're both identical, and they both have dimensions of 5 times 15. And then since there's 2 of them, we'll be multiplying by 2. Next, we'll look at the top and bottom. Those 2 are identical, and those 2 rectangles have a dimension of 4 times 5. And then lastly, we have the front and the back, and I'm going to designate those with little circles here just to notice they're the front and the back, and those dimensions are 4 times 15. Notice that the combination of the dimensions utilize all 3 measurements. They're just different combinations. We've got 15 in the 5, 4 in the 5, and then finally 4 in the 15. So let's figure out each of these. 15 times 5, 75. 75 times 2, 150. 4 times 5, 20. 20 times 2, 40. 4 times 15, 60. 60 times 2 is 120. If we add all these together, 150 plus 40 plus the 120, we get 310 for the total. And that is in square inches. Alright, and that's how we find the surface area of any rectangular prism. Just keep in mind you have 6 total faces, 3 sets of 2 of them. You have to figure out what each of those sets are and then add them together at the end. Let's look at one more, and this is probably the most complicated one of all of the ones that we've done today. It's not a rectangular prism, it is just a it's a type of prism, different shapes. There are quite a few pairs, and what we need to do is identify each pair. Then, like we did with the rectangular prism, we will add them all up and get a total surface area. Alright, first 2 that we're going to look at, notice we have this one and then the same one underneath. Those are 2 rectangles, and they're both 14 times 6. So I'm going to note those up here. 2 times 14 times 6. Okay, next we have this side here that we can't see very well, but the dimensions of that square is 8 times 6. Notice we have one here, and we also have one here. 2 8 by 6 rectangles. I'm going to note those right here. Alright, next up, let's focus on this rectangle, and then there's another one which I believe is the same dimensions. We'll check to make sure. So this side here is 6. This side here is 14 minus 8, and I get the 8 from subtracting this distance here from 14. Notice how it matches up. 14 minus 8 is 6. So basically it's just a square, a 6 by 6 square. We will also have that 6 by 6 square right here on that side that we cannot see. So we have 2 6 by 6 squares. Let's note that here. Yeah, part of this you kind of have to look at it even though we can't see all of it. You have to sort of deduct what's happening on the other side that we can't see. And finally, we have this L-shaped figure in front of us. In order to figure that out, we're going to break it into 2 rectangles. And actually it turns out to be a rectangle and a square. Okay, so we have right here, I'll note this with a circle, an 8 by 8 square, and we're going to have 2 of everything. So let's put the 8 by 8 square here, and keeping in mind there's one on the back. Let me kind of note that there's one on the back side here that we can't see. And there is also a 6 by 14 rectangle right here. I'll kind of note that with a star here. There's the same thing on the back. Noting that here in our work. Now we're going to take the time to calculate all of these and then add them up. 14 times 6, 84. 84 times 2 is 168. Our first area up here is 168. 8 times 6, 48. 48 times 2 is 96. That's our second one. 6 times 6 is 36. 36 times 2 is 72. 8 times 8 here is 64. 64 times 2 is 128. And the last one, 6 times 14, gives us 84. 84 times 2, 168 yet again. Alright, we're going to add all those up. Take a minute to do that here. And the total comes out to 632. And we are measuring in feet, so it's square feet. And there we are.